Welcome back from an ad break. So as we have said before, we're going to start with our first concept, which is the metal hydroxide and what are the metal hydroxides. So the metal hydroxides, they are formed during a reaction of a metal with water. So when metal reacts with water, we are going to get our metal hydroxide. Or if we are having a reaction of a soluble metal oxide with water. So again, we can either have a soluble metal oxide that is reacting with water, then we can get our metal hydroxide. So we do know that the hydroxides, they always have the OH. So the hydroxide would be the OH, whereas the metal could be any element that is found in either group 1, group 2, or basically in between the periodic table, whereby now you know that in the periodic table on the left-hand side we have the metals, then on the right-hand side we have the nonmetals, then in between the nonmetals and the metals we have something called the metalloids. So the group 1 elements, we do know that they are called the alkali metals, and the group 2 elements, we know that they are called alkali earth metals. So we can either use any of those two metals to form our metal hydroxides. So now, the metal hydroxides, they are bases, and we do know that. How do we know that substance is a base? The pH of that particular substance needs to be above 7. So it needs to be above 7, and the further you move away from 7, the stronger the substance becomes in terms of its basicity. Furthermore, the group 1 metals, as we have said, these ones, they are called our alkali metals. So they react violently with water to form our metal hydroxide. So we can take, for an example, a lithium. So when lithium reacts with water, it forms lithium hydroxide. So this is our lithium reacting with water, forming our lithium hydroxide. As we have said, all the hydroxides, they have the OH, as you can see there. Remember that the lithium has a chemical symbol of capital letter I and capital letter L and small letter I. And all the hydroxides, they have the OH within them, which is now the oxygen and the hydrogen. So furthermore, about the metal hydroxides. Metal hydroxides from group 1 metals, they are strong bases. So whenever we use any element or any metal from the group 1 or from the group 1 elements, those are going to be forming the strong bases. That means their pH is way above 7. It's closer towards the 14. We can even, for instance, look at another example of sodium hydroxide. We know that sodium hydroxide is a very strong base. So its pH is closer to 14. However, other bases, they can still be closer to 7, which means they're going to be weak bases. So the closer you are towards 7, or closer you are around 7, that's the more weaker you become. So you can either have a weak acid or a weak base, depending on which side we are looking at. So then, an acid and a metal hydroxide neutralize each other when they react. Now remember, this neutralization depends on the strength of the acid and the strength of the base that you're talking about. So should the amount or should the strength of an acid be equal to the strength of the base that is reacting, then the two reactants are going to neutralize each other. However, should the strength of the acid be greater than the strength of the base, then that means the product is going to be more acidic, because the product depends on the strength of the substances that we're reacting. You can also have a strong base that reacts with a weak acid. So it tells you that the product that is going to be formed there will be more basic as compared to it being acidic. Why? Because the strength of the product depends on the strength or the relative strength of the acid and the base that reacted initially. So an acid and a metal and the metal hydroxide, they neutralize each other when they react. And note that that's only if their strengths are equal. Furthermore, the general word equation for the reaction is whenever we are reacting an acid with a metal hydroxide, the products will always be salt and water. So we can rewrite this equation as an acid plus our metal hydroxide reacting to form salt and water, to show that it is a reaction, salt plus water as the products that are going to be formed when reacting the two substances. In addition to that, we can look at certain examples of this particular reaction that you're talking about here. So the examples of a reaction between an acid and a metal hydroxide, we can look at the hydrochloric acid and the sodium hydroxide. Then it's worth noting that these two substances, the acid and the sodium hydroxide, the hydrochloric acid and the sodium hydroxide, those are strong substances. So the hydrochloric acid is an extremely strong acid, and the sodium hydroxide is also a strong base. So that means when these two substances react together, they're going to form a neutral substance because their pH, they are almost relatively comparable to each other. Now, the product of these two reactions, of this reaction is going to be the sodium chloride and water. So that means we have the HCl, which is the chemical formula of the acid. Remember, all the acids, they have the H in front of their molecular formula. So hence the H there. And then the sodium hydroxide, the hydroxide meaning that there's an OH. And then we know the acid is going to donate its hydrogen, and then the base is going to donate its OH. And now when these two substances react together, they form our H2O. Why is that? Because we have one H there and another H there, so that's two H's, and together with that O to form H2O. Then the remainder of those two substances is going to be forming the salt. So the remainder here is your Cl, and the remainder there is your Na. So when these two substances react together, they form our NaCl, which is our table salt, what we use on a daily basis when our parents cook. Then the acid, as we have said, will contribute to the hydrogen, and the base will contribute to the OH to form the water molecule. Then now, the remainder of the acid and the base combine to form the salt. So as we have said, the acid is going to donate the hydrogen, and then the base is going to donate the hydroxide, and then the remainder, after the donation, the remainder is going to be forming the salt. Now this particular salt, the strength or the pH of this salt will depend on the acidity or the basicity of the substance which we are reacting initially at the beginning of the reaction. In that particular case, we learned that the hydrochloric acid is a strong acid, and the sodium hydroxide was a strong base. So when those two substances reacted together, the product, which was the NaCl, the salt, was neutral because the two substances, they neutralized each other. The acid was strong, the base was strong. So none of them was stronger than the other, hence the product was neutral. And of course, the byproduct will always be there as our water. So before we go to our next concept, we're just going to go for a quick short break, and I will see you just after this.